Welcome to Showed Up Sir classes. So this is a question from ISI M.MATH paper 2022. So this is the MCQ part for PMA in the code. So if A belongs to M3R, then which of the following statement is not true in general? So there are four options. So notice that you have been asked to find which one is not true. So if first option is f is diagonalizable, then a square is also diagonalizable. So taking the first option, so if a is diagonalizable, then P inverse A of P will be equal to some diagonal matrix which is D. Then P is also invertible. And when A is diagonalizable, so we may write that this P equal to this P inverse A of P is equal to some diagonal matrix. So then P inverse A of P, so if I multiply it with P inverse A of P, so that is D dot D, which will be P inverse A square P equal to D square. So D square will be diagonal. Why? Because D is also diagonal. So if A is diagonalizable, then A square is also diagonalizable. So it is a true statement, but here I have to find which is not true. So in that case it is not true statement. It is a true statement. Okay. So let check with the second option, that if so this option is A. So let's start with option B. So if A square is diagonalizable, then A is also diagonalizable. Okay. So A square here is telling that it is diagonalizable. Okay. Now take A equal to this your matrix is 0 1 0 0 0 0, be a 3 by 3 matrix at the diagonal of all the zeros. So in this case A is not diagonalizable, right? So this option, but here you can find that A square will be equal to 0. So this option B is not true in the sense that if A square is diagonalizable, then A is not diagonalizable. Okay. So this is our incorrect statement. So let's check with the other option also. So in the option C, there exists a polynomial P of degree 3 such that PA is equal to 0. So this is true by Cayley-Hamilton theorem. So what is the Cayley-Hamilton theorem? Let's just review it. Cayley-Hamilton theorem. So all real and complex square matrix will satisfy their own characteristic equation. Okay. So this is the theorem is stating. So this implies that when a square matrix is transformed into a polynomial, then this polynomial P of A equal to C, which is already the statement given in the option C. So option C is true. Now option D is A has a real eigenvalue. Okay. So the characteristic polynomial of A is degree 3. Okay. and which must have a real root. This because the characteristic polynomial of the matrix A, it is a degree 3 polynomial. With real coefficients. Okay, so it must have a real root, so A must have also a real root. So this is also have a true eigenvalue, real eigenvalue, so this D, option D, is also correct. So the incorrect statement is option B. Now next is the question number 2. So let V be a vector space with over R consisting of all polynomials with the real coefficients. Now if this consider the subset W of all polynomials of the degree 4, then which of the following statement is correct? So this will start with, so V is a polynomial of degree less than equal to 4 of real coefficients and W is the subset of all the polynomials of degree 4. So W will be suppose it is a P which is all belongs to the element of this V, and it has the degree equal to 4 already given. Okay, so let P be h of x to the power 4, this is a polynomial of degree 4 which belongs to the set W, and Q be x to the power 4 which is also an element of the subset W. Then if we do this P minus Q, so it will be h x4 minus x to the power 4 is one which is not a member of the subset W. Okay, so from this we can say that W is not a subspace of the vector space V. Okay, so the option here is the correct option will be A. So we have to find which of the following statements is correct. So the correct option is option A.